Okay, so this question involves a function telling us it's about a sketch with a curve of the equation y equals a function of x. So therefore it looks likely it's going to be involving the function rules. So we've got to remember what they are. So we've got to remember things like if we've got an original function and we do something to the function inside the bracket, then that means it's translated by negative a 0. If we do something to the function and we do it outside the function, so maybe a negative outside the function, then this causes a reflection in the x-axis. If we take a function and we just add a constant to the outside of it, then again that's a translation of 0a. If we take a function and we do the negative inside the function, so inside the bracket, then that's a reflection in the y-axis. And if we take a function and we do something inside the bracket by timesing the x values by a scalar a, then that's the same as stretching parallel to the x-axis by a scale factor of 1 over a. So in other words, the x coordinates multiply by 1 over a, and if we do a f of x, so if the function changes to doing something times the function, so the times in the scalars outside, then that means the y coordinates are multiplied by a. So those are the function rules that we need to be working with. So let's have a look which one we're going to apply. So here we've got a constant happening inside the bracket. So this looks like it's going to be the translation rule here. So the translation tells me that it's going to be minus a 0. Well, the a value was negative 3. So minus negative 3 is going to be positive 3, 0. So this means the coordinate will move 3 places to the right, but not change in the y. So it's not going to go up or down. So the coordinate answer here is going to be 5, negative 4. This one, the function's being changed by a constant outside the actual bracket. So this is going to be again a translation, but this time it's 0a, the a value being negative 5. So this is going to be a translation of 0, negative 5. So in other words, the 2 remains the same, but the negative 4 has to move down 5 places, so it becomes negative 9. So the coordinate here will be 2, negative 9. This one is telling me that we're applying a negative to the outside of the function. So that one is this one here. So it's a reflection in the x-axis. So that means this point is going to reflect across the x-axis and go up here. So it's the x value will stay the same, but the y value, negative 4, is going to flip over to positive 4. So the answer here will be 2, 4. So it's a reflection through the x-axis, 4 away there, 4 up there. And this function is always a reflection in the x-axis. This one we've got a scalar inside the bracket, so that's our scalar 2. So that means I'm multiplying, so I times the x coordinates by 1 over a, x coordinates by 1 over a. So that's going to be times by a half. So in other words, we half the x coordinate. So when we look at this, we've got half of 2 is 1, and we've got the negative 4 doesn't change. So the answer here is going to be 1, negative 4. Okay. The curve of the equation has been translated to give this curve. So in other words, the original function x squared had a minimum point of 0, 0. And what they're showing us is that this curve has had something applied to it, a function applied, a function change, and the minimum point now has gone to 2, negative 4. So therefore we started off with x squared, and we applied something to x. Well, to get it to move 2 places to the right, that means we must have used the rule here. So that means x minus 2. Remember, the translation is negative the a value. Well, if it's moved 2 places over, then that becomes negative 2. So let's take away 2. Squared, of course, because we're talking about a squared function. So we'll be careful here that we recognise it's a squared function, so let's put the square sign. That's taken care of the 2, and then the negative 4 tells me that we've moved down 4 places, and so therefore that must be something to do with the translation downwards, and this is going to be the application here. So to move it down, we must have something outside the function itself, outside the bracket with the function in it, the function letter, x, and therefore we're going to take away 4. So f of x has become x minus 2 all squared, take away 4. So that's transformations of functions involving the function rules.